Okay, we are ready for another round of proofs. Hopefully you guys are making this. You can see here we've got corresponding parts of congruent triangles are congruent, otherwise known as Cpctc. It's an acronym to help you remember that. Well, what does that even mean? Let me talk you through that. We're going to use this in our proofs today. Let's say you know already that triangles are congruent. Maybe you've already proven it. Maybe, like in this example right here, you've stated in a proof that these two triangles are congruent. You know, we're going to use one of those shortcuts for congruence, either side, 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 angle, side. What else have we got? Angle, side, angle, the side between the angles, or if that side is outside of the angles, we got angle, angle, side. We also added in the last lesson the hypotenuse leg option. So all of these would be reasons in a proof that triangles would be congruent, but maybe you're not going to stop there. Today we're going to go on a little bit. We're going to prove the triangles are congruent, and then we're going to move on to new conclusions. So let's say you already know these triangles are congruent. What would SR have to be congruent to? Well, if we look here, our correspondence is set up. We've got SR, and that's going to have to be congruent to GT. So SR would be congruent to GT. That just goes right back to that lesson, I think it was 4.3, where we just defined what we meant by congruent triangles. If the triangles are congruent, then we would know that the parts that would be matched up together are going to be congruent as well. So that is just simply the definition of congruent triangles. Triangles that are congruent have all their parts congruent. Oops, sneak in the triangles congruent there. Definition of congruent triangles. Or another way to say that is right up here. Corresponding parts of congruent triangles will be congruent. They'll match. And so instead of saying definition of congruent triangles, we are going to use an acronym, Cpctc. It's the same thing. If you are more comfortable with just saying definition of congruent triangles, you're allowed to do that. Cpctc is something you'll also see. So essentially, once we prove the triangles are congruent, this is our strategy, then all the corresponding sides and angles will also be congruent. And that, again, that is just saying the definition of congruent triangles, or Cpctc. Corresponding parts in congruent triangles are congruent. That's something you need to memorize what that means. So let's try this in a proof. Looky here. We're not proving the triangles are congruent. We're going to prove that some segments are congruent. Well, those segments are parts of triangles. So let's start out like we have been, and let's see why these triangles are congruent. We are given that xj is congruent to hi. Let me mark that. Xj is right here. Hi is right here. We also know a little bit more about xj, and it's parallel. We've flipped it around to ih, same thing, parallel. So I'm going to mark those with the arrows. These are parallel lines, or parallel segments. And why is that going to help me? Well, you remember that parallel lines, we studied this back in the last chapter, parallel lines, if they have a transversal running through them, they make some alternate interior angles that are going to be congruent, like right here and right here. So that's going to happen in our picture too. We're going to be able to say that this angle right here is congruent to this one by alternate interior angles. And then what else do we know in this picture? How about the shared side? That reflexive property is coming to the rescue one more time. So do we have enough? Looks like I got two sides. I see this angle included between them. That's on both triangles. So these are going to be a side angle side relationship for these congruent triangles. So let's just write that up. Okay, let's take care of those angles first. We already said here that these are parallel lines. That's a given. So what's the name of those angles I marked? That's going to be xjh, angle xjh. That angle there is congruent to, let me read this one, that's an IHJ. So, bam, we got the angles congruent. And we used our alternate interior angles theorem. Alternate interior angles are congruent. Okay, what else did we mark? Well, we have the given sides. That was the one in red. Let's write up our shared side there. So we've got our shared side is HJ, shared by both triangles, congruent to HJ. And by now you should know and love this. This is the reflexive property. And so we've proven the triangles are congruent. Let's make sure we've got everything written up here. Right here I see my side. Right there's my angle. And right there is my other side. So I've got triangles congruent by side, angle, side. Let's get those named correctly. I'm going to start with X, go to J, and then H. So let's call that triangle X, J, H. course, you can mix those up. I'm just going to match it up when I do my next one. Well, what angle would match, or what vertex would match x? That'd be I. So I said x first. I'm going to say I first. J, of course, matches up here with H. We mark those congruent. H comes next, and then J gets there last. So we used our side, angle, side to prove those triangles were congruent. Okay, that's all old stuff. We've been practicing that for the past couple of lessons. Now, like we say, we're going to prove that the triangle segments are congruent. If the triangles are congruent, then these parts have to also be congruent. In fact, let's see where we've got X, H. X and H are in the same exact place as my I and J, and so those are congruent segments. XH is congruent to IJ or JI. You can name it either direction. And this is our new statement. This is Cpctc. You want to say that corresponding parts of congruent triangles are congruent. Say it 3 times fast. You need to memorize that. Also known as the definition of congruent triangles. Awesome. So line 6 is just a doodle zone. We got it? All right. Yay. Angsty face. Okay, so let's try another one. Another proof here. You guys got a lot of proof in this one. We're going to mark it, answer it, and we're going to prove it again. Look here, we've got parts of our triangles congruent. This time angles that we're going to prove congruent. Let's go ahead and mark what we know. We've got our given segments, BA congruent to BC. And we know that segment BD right here running through the picture is the angle bisector of ABC. Right up here at angle B, we have an angle bisector cutting angle B into 2 congruent parts. So because it's an angle bisector, I've got congruent angles right here. And what else can we mark? How about the shared side? Bam. And that gives me enough to say the triangles are congruent. So what's my shortcut? Looks like I have a side here. I've got an angle. Oh, this is another side angle side. We're giving that a little too much playing time. So this is going to be by side angle side. And then once we say the triangles are congruent, we'll just go one more step and we'll say that those angles A and C match by the corresponding parts of congruent triangles are congruent. Okay, it looks like our given statements, we had 2 of them and they were split up. I can see that right off. So on number 1, definitely this is a given. BA and BC matches. We had that told to us right there. And the other given is what they want us to write right here. So BD is the angle bisector. Angle, I'm going to abbreviate this because I'm not going to be able to fit this in there. Bisector. Ooh, there goes my writing. Ha! That's one of the worst I've ever done. Of angle ABC. Good thing it's written up here so you can really read it. That's a given. All right, so how did we know that we could mark the angles right here? It was because they told us right there that we had an angle bisector. So I'm going to take care of those angles. This is a direct result. I've got an angle, let's say here on the left, ABD. And I'm going to say that's congruent to the angle over on the right, which is CBD. And I would not have known that had they not told me right there that was an angle bisector. So I'm using the definition of the vocabulary word we've got of angle bisector. Definition of angle bisector is it cuts it into 2 equal pieces. Definition of angle bisector is my reason. Alrighty, so we've got that taken care of. We've written up our side and our angle. We just need to talk about this last side. Our reflexive property is going to do that for me. So I'm going to put down in here that segment BD is congruent to segment BD. And reflexive property. And then I've got to say my triangles are congruent. So what are the names of my congruent triangles? I've got a triangle named ABD. And if I'm going to match all of that up, what would match up with A? It would have to be over here at C. So I'm going to start with C. Triangle C, then follow it back up to B again, CBD. And we used our side angle side as our reason. And so the triangles match. If the triangles match, then their corresponding parts match, and one of those corresponding parts is angle A here and angle C here, exactly what I was supposed to prove. So I'm going to write that as my last line. Angle A would have to match with angle C, since corresponding parts of congruent triangles are congruent. And there it is. 2 big proofs and a new theorem, or definition, really, the definition of congruent triangles. And I say that that deserves a victory dance.